In August, the European Space Agency will launch its latest Earth Explorer mission, Aeolus. The mission aims to further improve our understanding of winds and help increase the accuracy of weather forecasts. But this new satellite is unlike any other. For example, its shipment to Kourou is by boat rather than plane, because the sudden increase in atmospheric pressure upon landing could damage some of its delicate instruments. Aeolus is also the first space mission to acquire wind profiles on a global scale. This wind data is needed to create weather forecast and climate models. Today, meteorologists have to analyse winds by using weather balloons, tracking clouds, measuring temperature and looking at sea waves for surface winds. These methods, however, have severe limitations and give insufficient data.
All of these systems are not measuring all over the globe at all altitudes from the surface all the way up to the top of the atmosphere. And in order for the model to get the winds right, they need more observations. And this is where the Aeolus satellite will come in. Aeolus will measure winds from the surface or from optically thick clouds all the way up to 30 kilometers and filling a gap in the current observing system of the Earth for forecasts.
To detect these wind profiles from space, Aeolus uses a powerful laser called Aladdin, which stands for Atmospheric Laser Doppler Instrument. This instrument ejects an ultraviolet laser beam through the atmosphere. The air particles in the atmosphere, which are moving because of winds, reflect some of this light back to the spacecraft. By measuring the shifting frequency of this backscatter, Aeolus can detect the wind speed and profiles at different altitudes. Aeolus is the first satellite to use this technology in space. This is why its development has been a long and costly process. The satellite is both a technological marvel and a real challenge.
We pulse our optics 50 times every second, and this goes on year after year. And this intense pulse creates 1700 degrees on the optical surface of the optics and will fatigue the optics in long run. So we've had tremendous developments of the coatings of optics and to withstand this high pulse, laser pulse ability. We are actually our own sun, if I may say.
Despite its more than 16 years of development, Aeolus overcame all difficulties because the mission was of great importance to the scientific community, who have requested data on global wind profiles for the better part of 2 decades. Due to its low altitude, Aeolus will have a lifespan of only 3 years. However, ESA hopes the technology will be continued on similar satellites in the future, as the understanding of wind profiles is a key factor for meteorological and climate models which benefit us all.